Welcome to the Crazy Wisdom Podcast. I've got Larry Swanson here, and he is the creator of the Knowledge Graph Insights podcast. And this is our second episode. And before we begin, Larry wants to talk about something we talked about on the last episode.
Yeah, I have to correct the record. I mistakenly said that AI, which I had heard many times, was like a marketing term that was made up at that 1956 Dartmouth concert. But actually, I have a friend who used to collaborate with John McCarthy, the guy who convened that conference. And the term was actually invented to disambiguate what they were doing. There were sort of two camps in AI at the time. Norbert Wiener was one camp, and he called what he did cybernetics. And the stuff that John McCarthy was doing, it's kind of similar but different, different enough. And there's kind of, I don't know if it was a spirited rivalry, I don't know exactly what the distinction was, but they wanted to distinguish their event from the cybernetic stuff. That's where the term AI came from. They were like, AI, artificial intelligence. That's right. That's what we'll call it. So the true origin is more, it's not as snarky. It's not just a marketing term. It was it is kind of a branding thing. It's like, hey, what are we doing here? It's not cybernetics. It's artificial intelligence. So,
wow.
Yeah.
Okay. And that ties a lot of things together because cybernetics, I've got a friend here who's been teaching me about cybernetics and about what he's learned from Wiener. He did a bunch of philosophy meetups here in Buenos Aires about Wiener and about kind of cybernetics. It's really interesting that and it seems like the AI camp totally won. They must have, except the cybernetics still feels like it influences a lot of thought, but within the AI stuff, it feels like that the AI is pretty dominated by the people from John McCarthy.
Yeah, that's true.
Is that right?
Yeah, that's how it feels, doesn't it? Yeah, I hadn't thought about it that way, but you're right. I think in terms of like the memes, the labels taking hold, AI seems to have, stood the test of time way better than cybernetics. I think cybernetics kind of endures mostly as like the root of cyborgs and things like that,
Yeah.
cyberspace, and it's become a prefix.
Yeah, it's more sci-fi. The AI is pretty sci-fi right now.
Mm-hmm.
So, and it's so interesting because now the LLMs, and I want to talk a lot about AI with this episode, the SaaS apocalypse, as you were talking about it. And for reference there, we are using a tool that I have vibe coded since our last podcast a few months ago, where we're now recording on this tool that is basically I've had in my mind for a really long time of how to basically remove all the SaaS in my life as it relates to podcasts. And so we can talk a lot about the AI stuff, but randomly, I forgot that our episode was on the calendar, and then randomly, last few days, I put off the knowledge graph stuff because it's so dense, and the ontologies is so dense, and it's so hard to figure out what's going on. And so I basically, because I've been deep in the weeds on real technical stuff that I've forgotten about it up until the last few days, and then I've gotten into it again because now it's coming up in a big way in terms of the chatbot. I'm now vibe coding my own chatbot because Claude has technically regressed. And regressed is a very important term here because regression means basically that it's no longer working to the same way it worked before. And a lot of people are complaining.
Is this a 4.7 thing? Or?
Yeah, exactly.
Oh,
exactly.
Interesting.
Yeah,
I haven't played with it yet. Okay. Yeah.
Mm-hmm. So we can talk about knowledge graphs, ontologies. We can also talk about vibe coding. What have you been learning over the past month or two?
Wow, so much. Right at Christmas time, one thing that really took off I'll focus on the knowledge graph part because one, I've actually, since we talked, I've interviewed two of the co-authors of the semantic web paper for my podcast in different contexts. And that's coming up, well, essentially right now. That paper came out 25 years ago, probably almost to the day that we're talking. It was in the May issue of Scientific American in 2001, which means the print edition probably hit my mailbox in Seattle about 25 years ago today. And so there's a lot of like, not I told you so, but a lot of like validation feeling in that community. In fact, I was just talking to last night I interviewed Aurel Asala, one of the co-authors of that paper. And one of the things we were talking about after the interview was the kind of other, I think we talked a little bit, I know we talked about Charlie Ivey's observation that the semantic web was the most successful failure in the history of technology. And Aura gave me a whole bunch more evidence for this. Like there's this metadata standard in every single Adobe product ever. All the illustrations and photos and AEM and all their products called SMX. It's a metadata format that's largely built on RDF, the same technology that powers the semantic web. So that's just one little random thing I've learned. Also, I'm also working on a talk I'm going to do next month for a group in DC about where I kind of, as I talked to both of them, Aura and Jim Hendler's the other guy I've talked with, I started picturing that Scientific American paper as like the culmination of a whole bunch of AI. We talked about this last time, the history, and we just talked about the 56 Dartmouth concert and the conference and the earlier work. And so in many ways, that paper was sort of the culmination of a lot that had happened before with this vision for how it might unfold in the future. That it hasn't unfolded exactly as they hoped it would, but it's unfolded in really powerful and ubiquitous ways. It's just everywhere. Like just this, and I'm sure I'll find more things besides what Aura said about that SMX standards. There's just, RDF is like, I don't know, it's like SIM cards or something. It's just, they're everywhere, but you never think about the SIM card in your phone. I think RDF is kind of the same kind of, it's everywhere, but we just don't think about it. And so anyhow, so back to what I've learned the last few months, that you probably saw that famous Foundation Capital article right before Christmas. I think it was December 22nd. They dropped the $1 trillion opportunity in context graphs.
Oh yes, yeah.
And that's inspired a lot. In fact, I just had another guy on the podcast, a guy named Daniel Davis, who started a company called Trust Graph. And they've been working on what they call a context graph for a couple of years. So well before that came out. And a friend of his, he turned me onto this video that was actually at the Knowledge Graph conference, which I've been to almost all of them. I missed the very first one in 2019. So I missed this guy's talk. His name's Vicky. It's a man named Vicky. He lives in Belgium. I'm forgetting his last name. And he did a talk. He was at the time with Calibra, the data catalog company. And they were talking then about context graphs. So that's sort of, in terms of like, and I think that arose probably from the confluence of all the discussions about context engineering in the AI world, the need to establish better context, and then this thing we also talked about last time. We talked about the neurosymbolic architectures. We have symbolic AI, knowledge graphs, and ontologies, and hybrid architectures with the machine learning stuff. And so all of that, it's kind of culminated in this like just ongoing conversation about, even what is context? Like that guy, Daniel, I just mentioned.
Where's my question? What is context? What is it?
Yeah. So here's a couple of definitions. Well, first of all, our mutual friend, Jessica Talisman, I've heard her say a couple times, like, context graph, that's like saying wet water. Because her point is that knowledge graphs do pretty much what a context graph would claim to be.
Interesting.
Yeah, Daniel Davis, he and others, I think he's the first person. He might be, anyhow, he says that it's like a knowledge graph purpose-built to assist AI. So like that sort of the flavor of a knowledge graph that would help out in a hybrid system.
How many different types of knowledge graphs are there?
Oh boy, that's a really great question. Because that kind of gets into like what even is a knowledge graph, that's another kind of marketing term. To be honest, that one really is, in the sense that the term had existed before then, but Google popularized it in 2012 when they launched their knowledge graph. So that's sort of how people think about it now. And the conventional description would be like an ontology plus all the stuff in that ontology. That all the concepts that an ontology covers, all of the instances that fit inside that ontology. And once you populate it with those instances, the ontology plus the data becomes a knowledge graph.
Okay, so the ontology is the formal, the ontology is the piece under which all of this stuff rests, right? So and then a knowledge graph is the extension of that into a company with a system. And Google kind of did the first one, and I think they did it for their search thing, right? And they tried to get everybody else to do it, right? But they couldn't, because all these small companies were like, I'm not touching that semantic web. Is that why?
Well, yes and no. It's interesting. I don't remember their exact. It was a teaching moment for them to talk about the benefits of semantic technology. Their paper talked specifically about things, not strings. That was the whole idea of their knowledge graph, that in an ontology, you're talking about things as distinct, as concepts, as distinct from the labels that you ascribe to them. It's a subtle distinction, but an important one. and one that that was well in process. That was, people had been doing that. People I know have been doing that for 20 years before that, and building things that looked and worked and walked like a duck, talked like quacked like a duck. They were knowledge graphs. They just didn't have that label yet. So in that sense, they were kind of new then, but just that conception. Well, and actually, let me go to another track that goes into that. One of the ways that in ontology engineering practice, there's a truism, like the conventional way that they think about it. I don't know where this idea originally came from, but have you ever heard of the T box and the A box?
No.
Okay, so this is a thing. I don't know which nerd came up with this. I'm just surrounded by delightfully nerdy people everywhere I go. It's great. This is the best life ever. So the way you describe, and this is how you describe, it's just another way of saying what I just said. The T box are the terms, the concepts that you have terms for in your ontology. The A box are the assertions, the things that you say, this is one of those. Like there's this thing in an ontology called a product, and Microsoft Word is a product. So that would be an instance of that. There's an interesting development in that. Like, I don't know, 3 or 4 years ago, I think there's a guy named Dave McComb. He runs a company in Colorado called Semantic Arts. He articulated what he calls the C box. And this kind of this is a little technical aside, but like all of this stuff in this world is built on RDF, that resource description framework, the subject, predicate, object, triple structure. And you can do a lot with that. You can assert you can assert what those things are by saying, this is a product. And in the concept part, the terminology part, you can also say that, like, here's this high level concept, but there are kinds of products. There are physical products and digital products, for example. You might divvy it up that way. So but in between that T box and the A box, among both of those things, both the things in the T box and the A box have a number of properties and values and attributes associated with them. And so there's like a lot of taxonomies and controlled vocabularies and other ways to describe the stuff in these knowledge graphs. And that's what Dave calls the C box. The quickest way to get on top of that is Katerina Kari. She's an ontologist at IKEA. She did a blog post kind of riffing on Dave's video about the C box and talks about the IKEA knowledge graph and why it has 3 layers.
It sounded like what you just said so I'll try to explain this to the listeners who might not know about all these details. So we have totally. Okay, so we have T box, we got A box, we got C box. It's like, so, oh man, sorry, this not normally doesn't happen to me. There's so many things going on through my head. Okay. IKEA, man. Okay. So we got an ontology, we got a knowledge graph. Where was I going with this? Oh, the metadata. So what you just described feels like a whole other metadata thing. And the reason why I was going to explain the metadata is that metadata is data about data. And I've been deep in the weeds on this because I've now got 5 applications and I'm not a large enterprise. A large enterprise, I realized in my looking through how do I get good metadata standards for my 5 applications, I realized I am not large enough enterprise to do any of this stuff, basically. I do think that AI will bring me there much quicker than traditionally, particularly once more people start joining me to do all these things. And so metadata is a way that basically large companies like IKEA can manage the complexity of their giant organizations. And that metadata is data about data. You just said the C box thing feels like data about T box and A box in the same way, right?
Exactly. Yeah, I think it's, I haven't thought of, it's a good lens to look at it through, but it's virtually it's almost all metadata in the sense that it's like, that the C box things there, they can function as metadata or faceted search things or, like facets or search? Attributes or, I'm sorry, say that again?
What is faceted search?
Oh, facet. That's a term from, it's interesting. It's a term from information architecture. You've seen this every time you've gone to like a books, like Amazon or Etsy or any kind of online shopping experience where you have like, no, just show me pants with, waist 34 and inseam this, or, this fabric, that color. It's all this, it's C-box stuff, now that I think about it. It's like, it's a way facets are it's like the logic, the grammatical use of the term. A facet is a face of a thing. Like, it's got this size, this color, this fabric, this,
Man,
yeah.
it's so crazy because it just goes back again. I'm sure we talked about it last time. Just how this entire thing is so perfectly timed for people like you and the people you interview, which is all of you have been trying to figure out how to do all these things that are now becoming essential to AI.
Mm-hmm.
But all the people in the AI stuff are all like, engineers who are all about determinism and have been thinking about deterministic things for a really long time. And it feels like a lot of them have some hubris around how much they can engineer around these things without going to this layer that you guys have spent a lot of time in, which is what is the nature of being inside of these things? How does language work? And how do we define these things, which is just so abstract. And as one of the people that I was talking about who had hubris around the limits of engineering, like that, it's just really complex. Taxes the brain because we have to think about language in this way that we've never thought about it. Is that accurate?
Well, yeah, no, and I think a lot of what you're saying is like the reason we need all this stuff is because the power of knowledge representation is its abstractness. That notion that you can just go back to here are the fundamental concepts and really thinking that through, because that's what gives the logical foundation of that, the thing that permits true reasoning. Like the stuff that LLMs do isn't really reasoning. It's like iterating on what they do. True reasoning is like logic based, and it's one of the things that RDF permits. But back to because my brain gets broken just like yours was every day. As I think about this stuff, and the thing that helps me hold it all together is these models that people have come with to explain it, like the T box, the A box, the C box. It's like once you have that. You can kind of tidy things up in these intermediate concepts, and you say, oh, products, they always have like a material and a color and a size. So and which might be thousands of items or millions of items in a vocabulary or taxonomy or something, but you don't have to worry about that. You can just tuck that away, abstract it out into this other artifact that manages that part of it for you.
So what are the limits of abstraction? Because this brings to mind a specific thing related to the ontology that I found out, which I just loved reading about, which was there's this thing in the 80s and the 90s called CYC, CYC. We might have talked about it.
Psych. Yeah, the Psych
Psych
project. Yeah. Doug Lynette. That's a whole other thing.
Can you share what it is?
Yeah, well, so it was an attempt to, Doug Lynette was a real genius, and this is another one of those things that's ostensibly a failure, but not really, in the sense that the project is currently being wound down. I know some people involved with it. In fact, I'll probably have one of them on my podcast soon, because he's going to try to port the Psych stuff into RDF, which is a really crazy, anyhow, that's a whole other story. But Psych was an attempt, and I don't know the details super well, but it was an attempt by this guy, Doug Lynette, and I think it was around the 70s or 80s, somewhere like that. He wanted to articulate logically and consistently common knowledge, like all the things that people know, like big things don't fit inside of small things. Distances between things dictate how long they'll take. I can't even think of all the concepts, but it's like, and it became like, I don't know, millions of concepts that they captured that way. And I think and the reason I say it was a success, even though it hasn't been adopted and taken off, a huge amount. Like I can't begin to count the number of people I've met in the knowledge graph space who were in some way influenced by the. In fact, 1 or 2 years ago, at the Knowledge Graph conference, Doug Lynette died a few years ago. He was posthumously awarded whatever their award is. I'm spacing on the name of it. But so he was super influential in the world of knowledge representation. And that kind of points at like, that was like his idea, and he built a whole project around it. The thing that's different about the knowledge graph space is that it's built on, collaborative standards. I just last night interviewed the leads of the RDF 1.2 working group. That's the extension of RDF that'll permit, mostly the main thing it's going to do is permit reification, which has been a real problem.
Reification, what is that?
Yeah, reification. So it's like to reify just means to make something real. And it's the ability to talk about things that don't necessarily exist if that may, or to reify something is to make it real. And one of the problems I'm not like a proper logician or mathematician, but some of the work that these guys have done, this team of, I don't even know how big the team is. I interviewed the two leads last night, but it's a group of really smart, these are all people who've been doing semantic web stuff for 20 or 30 years. Some only 10 or 20, but it's like a lot of really experienced and very smart people, working through the logic. And this gets back to the how to deal with abstraction. Yeah. They take it down, to the studs, down to the bare metal, like go down to, touching iron is like, hardware guys would say, you go right down to the basics and say, okay, we need to build this thing in a way that, for example, one of the things about the logic in RDF is that there's a lot of inference, and you say, okay, I'm trying to think of an example. It's always hard to come up with it, but anyhow, you create new graphs from you'll build a new graph from inferences you made on existing data, and that has to. Whoa. Yeah, it's really, again, like, I don't get the math. I mean, I conceptually get it, and I understand. The main thing I get about it is the intellectual rigor that's gone into the standard. And I think, and I don't know the fundamental underlying model of psych, but I don't think it was, and it was a big project. There were a lot of people involved in it, so I'm sure it was very collaborative, but I don't think there's something about the W3C standards. It's a really high threshold, and they didn't even call them standards. They call them recommendations, because that's the point of the W3C is to get to a level of rigor that they're confident, that the thing before what you'd think would be the standard, you'd think would be the recommendation, but it's actually kind of slid over by one. They call it a candidate recommendation, which is the status of RDF 1.2 now, it's pretty much ready to go, but it just has to pass muster with like the architecture team and the accessibility and the globalization teams at the W3C. So it's like a real, because this is powering the whole internet, it's like, and it's accessible to anybody on the internet, and it has to work for everybody.
So you said a lot of interesting things I want to dial into. W3C, there's an organization, and these guys are doing RDF, and they're extending the standardization framework, but the standardization framework is not like RISC-V or which is a hardware stack, which is a really interesting story behind it, or like USB-C. Like it's totally in this logical, abstract meta standard, basically. How much this W3C is like an organization that is like gardening this standards or this framework, but all these big companies depend on it. But not only big companies, like governments. Do governments depend on it?
Oh, governments are huge. Yeah, governments, cultural heritage organizations, enterprises. But yeah, governments and enterprises are probably the two biggest like consumers of RDF, if that makes sense.
Interesting. And they're like totally locked into this thing for a very core component of their businesses and their organization.
Yeah, well, I think a lot of them, like currently, I just today or yesterday dropped an interview with Veronica Heimsbach, who does has done a lot of work on the shackle standard, the shapes constraint language in RDF. And one of the things that drives the adoption of shackle, which is just another form of RDF, is the government requirements. There's government compliance requirements, mostly, I don't know how common they are in the US, but really common in the EU. And if you think about an entity like the EU, it's like, you got to know, if you're going to drive trains from one country to another, the rails better be the right width, that kind of thing. And so there's a lot of that kind of stuff happening in the EU. So I think government, compliance with government standards is a huge driver for a standards-based thing. And in fact, I don't know exactly how it works, but I know that to be a member of a working group at the W3C, your company has to sponsor it. So there's companies that are invested enough in this that they will sponsor the time of a person. Kind of like, I don't know if it's like, I picture like an open source project, where you budget sponsor X amount of time for your person to contribute to that. And so these standards are important. People get it. They're able to fund the development of the standards with smart people from big organizations. But I think that the main point about that is that they're typically like big organizations that fund it. Like Veronica, who's the woman I interviewed I just dropped, she's like probably the world's leading expert on shackle, but she wasn't on the standards committee just because she didn't happen to work for a company that was a member of the W3C.
Oh, interesting. So she created a whole other RDF type of open source, like
Well,
spin-offs,
she
basically.
no with the RDF. I think I don't know exactly how. It's really interesting where these things come from too. Like the OWL, that's the description logic based language. That's the really powerful part of RDF, and that's why the RDF standard has to be so solid, is so you can do real logical stuff over it.
Interesting.
But there was something I can't remember what it was called. But there's a number of for all of these things. There's often precursors in
Yeah.
earlier developments that
Wow.
like Pat Hayes, that guy I mentioned, who told me he's the guy who used to collaborate with John McCarthy. He was brought in by Tim Berners-Lee to kind of just as like the semantic web was kind of the idea was like, okay, we got to get data on the web. And then it's like, oh, now we got to get logic in the web, in the data.
Oh,
And so Pat was brought in to be like, I'm grossly oversimplifying that, but basically that's the story. Is like you needed like top not like
yeah.
Pat is one of those like world's leading authority on description logics, and that's the guy you want doing your logic for OWL and RDF.
So, and now, so now all of this is moving towards basically the fact that AI can't really reason.
Well,
But have
yeah. Well,
AI?
so this goes back to what you're saying about
Yeah.
the hubris, and I
Yeah.
don't want to diss any engineering friends because I love these guys and they're doing
Yeah.
amazing stuff. I use Claude every day. I really
Yeah.
appreciate this. I object to their bosses overselling it. That's not
Yeah.
cool, but that's a whole other thing.
Yeah. Yeah.
Yeah, that's but it's really clear. It's just like I've done a lot of work with decoupled architectures, and like one of the principles there is like separation of concerns. You get the tool that's right for the job. And
Yeah.
like to what
Interesting.
you were just saying, if you want to do reasoning, you probably want something that's based on some kind of formal logic. There's other kinds of logic besides description logic, but that's what I don't know exactly how they chose that for RDF and OWL. But so we're getting to the point in the evolution of AI where it's clear the power and the benefits of the symbol of the neural network based stuff, all the LLMs and GPTs and all that stuff. They're just amazing. They can do a lot, but they still confabulate. They're prone to
They're
errors.
not going away. Those problems are not going away. They're so big. They're so fundamental to everything that I run into every single day. It has no epistemological virtue.
Yep.
Like it just guesses and leads me down these rabbit holes that are maddening, and but I'm loving it at the same time because I love thinking about epistemology and like how to know what's true. And
Oh,
not many people know how to do it. I don't know how to do it.
No,
Many people.
I got some help in that regard. There's a great. Have you seen that paper, the epistemological fault lines between human and?
No, that's a great
Oh,
one.
you're gonna love this. You're gonna
Yeah.
love that paper. It's called the epistemological fault lines between human and computer intelligence.
Oh, beautiful.
A guy named Walter Quattrologio or something like that. There's also I'll send you the link. I just listened to a podcast with the lead author of that paper as well. But yeah, that epistemological disconnect is it's really that's a deep paper. They kind of take a really rigorous 7-step methodology to compare human language stuff and computer language stuff, and they're just way different. But the computer stuff happens to have this fluency and eloquence that it can muster. That to the frustration you were just expressing. It kind of explains that. You're going to love this paper, I guarantee it.
Because it's basically like it's so fluent. That you said it exactly right, and that's come up in the last few days. Is that it has fluency, but it doesn't have valuation. It doesn't have vision. It doesn't have judgment. It doesn't have all of these things that basically turns fluency into this thing that's real. So it can sort of manipulate me. But I'm also finding that, like, this would be a good question after I figure out how to explain it. There's it has this fluency. A lot of people worry about machine influence, that this thing is going to influence us in ways
Yep.
that we can't tell. I do think that there is an intellect, there is a sort of a baseline IQ that someone needs to be above in order not to do it. But in general, I think as long as people are above that line of IQ, the machine influence isn't a problem because of this fluency.
Actually, unfortunately,
Yeah.
Unfortunately, that's not the case. So, a
Yeah.
quick
Okay.
aside: I have a friend who
Yeah.
wrote a whole book about cognitive biases, and one of his
Wow.
favorite things when he talks about it, he talks about like, "Look, I can tell you about this cognitive bias.
Yeah.
Then I'm going to put you in a situation where it comes up, and you're
Interesting.
going to do it even because you know about it." The same
Yeah.
thing is happening with AI. There's another recent paper called "Thinking Fast, Slow, and Artificial," and he talks in there, and it kind of to what you were just saying. That paper shows that there's no baseline of like knowledge or intelligence that can keep you out of trouble with these things. That even if you know what's going on, you will. I think what does he call it? Cognitive surrender, I think, is the term he
Ooh,
uses.
I like it.
That like, yeah, I think I've read a bunch of papers lately. I might be conflating that, but I think that's the term they use in that paper. This notion of cognitive surrender, that they're because they're so fluent and they're right. So they're right. What 90% of the time, 85,
Yeah.
99,
Okay.
depending on the arena you're in, they're right a lot. So you kind of get both lulled into confidence, they kind of, lull you into false sense of security, and then like come up with some, something that doesn't track. So there's, so that's another thing that's going on is like, it's not just like that epistemological disconnect. There's also like, this is more like the flip side of it, the
Yeah.
behavioral implications of it, that we, just in the same way, it's kind of like they're inventing new cognitive biases. These are machine biases that we fall for. So unfortunately, because I was with you, I was thinking, I can figure this out. I understand how these things work. I can stay out of trouble. It's like, nope. That paper shows that we're going to be duped just like everybody else. So. Yeah.
But maybe there is something in that sense, is that as long as we can retain the humility to understand that we're always biased, maybe that is a way out. In this, but machine influence, okay, and then persuasion. I want to go back to this epistemological fault lines, because that seems really important.
That one is really, that one kind of gets it like the fundamental. There's another paper kind of in that same family about the disconnect between language and cognition. This is a much more subtle thing, and it's not super clear cut, but there's evidence that I think a lot of people think of cognition as an internal dialogue. Your brain talking to itself, kind of working through something. There's evidence that people with severe language impairments, like aphasia after a stroke or something like that, they can still think. In fact, I have a friend, a really smart guy, who had that and knows exactly what I'm talking about. He goes, "Oh yeah, I had that, and I couldn't articulate anything in language, but I was solving complicated math problems in my head."
Yeah.
And I think this kind of gets in like the Rain Man thing and phenomena like that. So between that epistemological fault lines thing, the cognitive linguistic, like we think, because I think the importance of that cognition versus language thing, it's not the exact same thing, but I think because large language models are literally just language, they're just tokenized embeddings of language things that they then stitch back together. There's no real actual thinking going on in there. There's a lot, just as in our own brains, there's probably enough language is probably 80 or 90% overlap with language and cognition that you can actually think through a lot of problems. But there's probably a lot of stuff that you just can't language your way out of, that you need this additional cognitive capability. Anyhow, that's just me extrapolating from this one article.
No, well, but then the Google, there was a paper that the Google DeepMind people brought up recently, which kind of is, they declared surrender in terms of, okay, we have no idea how we're going to get machines to be conscious. That LLMs are doing exactly what you just said. I didn't read the paper, so don't take me on it. But I got the gist of it, which is like, it seemed obvious to me that we're so far away from that. But I want to go into this reasoning thing, because they call it reasoning. And now I'm building my own chatbot, and that chatbot basically is going to try to recapture what I lost with Claude as the ultimate thought partner. Which with 4.7 they made changes to their reasoning. So they have adaptive reasoning now, which means that the model itself chooses the level of reasoning applied. Previous to this, they would give me the choice as the user, and so I would always do max reasoning. Why not? And that's what led them into the problem that they're running into, which is they don't have enough inference servers. They can't do enough inference to give people like me a 200 USD subscription, all you can eat, And that was interesting to go through that for the past 2 months, where all of a sudden the service that I was paying for got worse and worse and worse and worse. And now with the final blow with 4.7 has basically destroyed the chatbot as my personal counselor type of situation, and who could help me think through situations. So now I'm realizing that they're trying to serve too many people to help me in this specific thing that I was getting a lot of value from this personal thing. And so now I'm starting down this quest of how do I build a chatbot that brings me back to a year ago with Claude. And the problem I'm running into is that they have built this model, they've built the harness around the chatbot, and they've fine-tuned it for various things, basically. Building the model and the fine-tuning way outside of my budget. Those are hundreds of millions of dollars things. Those might get cheaper and cheaper. But what was the third one? The other one is this thing that I do think that I can recreate, which is just like me as a person. I have particular values that I can instill into my software, which I've been learning with the SaaS apocalypse that I can do now. I can do that with all the other softwares that I'm building. But how do I do this inside of a chatbot, inside of this thing, to recreate this thought partner that I had that I don't have? Do you have any thoughts on that?
Yeah, well, the first thing I think of is like, and I haven't had a chance to do this yet, is the notion of, because some of this, it's interesting the way some of this stuff declines in quality with scale. And I've heard a lot of things from the other side of the benefits of small language models, like domain specific things. Sure. I haven't had a chance to play with it. There are a couple benefits of those. One, they're often small enough to fit on your laptop,
I gotta start playing with
your
these.
iPhone. Yeah.
Ooh, that's a good one.
Yeah. So that's like, I've got a bunch of things bookmarked about that. I haven't really had a chance to dive into that as much, but I think that,
I got to start.
Especially when you're, and this kind of tracks to one of the things that you hear designers say a lot, and even some product people, about the role of humans as AI unfolds. And it's that notion of taste and discernment and judgment and those things that you can have. Again, it goes back to the language thing. You can have language about tasteful things that people have talked about, but you don't have that thing in your head. There's no head. There's no. That's one of my favorite memes I've seen lately. Is like the picture of your AI girlfriend, and then your AI girlfriend without makeup, and it's just like an exploded view of an NVIDIA GPU. It's pretty great. But so there's no staring up at the stars at night thinking about how the world might be better. It's just like language that other people have described similar experiences with. So I think, but I don't know how exactly. One way you get that into systems is like the knowledge representation stuff that in my world, that like so much of, proper knowledge, just not even, we talked about this last time too, the difference between, machine learning, knowledge engineering, and knowledge management. And that once you get into, from even just, not just, but knowledge management and knowledge engineering both are concerned with getting that tacit knowledge out of people's heads and capturing that. And especially in the case of knowledge engineering, capturing it in a way that you can do, stuff with computers with it. And that's the closest we might ever get to human discernment. But I think even with that, I don't know that we're going to replicate, whatever like happens in Steve Jobs' head or Albert Einstein or, Da Vinci or Michelangelo.
We'll never get to, or it'll be very far long until we get to knowledge representation of genius. Is that?
Yeah, well, that's the kind of thing I wonder. I do this presentation about, that data, information, knowledge, wisdom pyramid that we have. I have a little tiny top bit at the top of that reserved for stuff that we'll never get in computers. You never really get that ineffable human insights that just. And I think that's, I mean, maybe I'm just being overly hopeful about it, but I really do feel like, but I also think just from a technical
structural to the universe, it could be structural to the universe that we just never get. It's not possible to actually do that.
Yeah. That gets into like Michael Pollan's notion about consciousness. I just only recently got introduced to that, but it's
what did you learn from that?
Basically, that rocks could have. I mean, this is again a gross oversimplification. This is based on one podcast that he did with Ezra Klein, where they talked about his book. What's it called? It's about consciousness, and it talks about that one of the possibilities of what we see as consciousness is that it's a thing that exists that we just are expressing or understanding or feeling or something like that. I don't really get it, to be honest. But the idea that consciousness is a thing that already exists and that we just access it somehow, as opposed to it emerging from our, this is the way I think about it, like from a evolutionary biological perspective, is like like I used to, years ago, my last textbook job was with a brilliant biologist named Neil Campbell, who used to say this thing. He would tell these stories at sales conferences and stuff, where he'd always start with like, what evolutionary sense does that make? And he could explain everything through the notion of adaptation and evolution. And so it's not hard to imagine, like, neurons and axons and and even myelin sheaths and all this like crazy complex physiological architecture that we carry around, that evolving in some way to have us think in a way where we think about ourselves.
Yeah, interesting.
Yeah. But again, this is way over my pay grade.
So, and the book, I looked it up now. It's How to Change Your Mind: What the New Science of Psychedelics Teaches Us About Consciousness, Dying, Addiction, Depression, and Transcendence. Psilocybin, LSD, 5-MeO-DMT, ayahuasca, interwoven with the history of the psychedelic research suppression in the 60s.
Yeah.
So I think it's time now to go read that book, because I've been fascinated by what's going on in the 60s lately. Yeah, it's like, and then you talked about subjective awareness. And so we have consciousness and we have subjective awareness. And we have a lot of people who think they know what those things are. And I certainly don't know what those things are. It goes back to that epistemological thing. It reminded me of a meme that I won't try to get out. Well, actually, never mind. So basically, what is consciousness? Well, that's a 3-hour podcast, and we'll never get to the root of it, right? Because like that's been the primal attempt of all of humanity to figure out what's going on. Yeah. And we're just like, and then to ground it, let's go into the LLMs, because it's like, I think both of us agree that the LLM is not there. There is this sort of Michael Pollan sort of like, I think panpsychism is the word, is like, well, consciousness is fundamental, so everything we see is consciousness. But that might be the case, but also I think it's far away from us being able to grasp those principles of the universe to do that. So we're stuck at this LLM phase, and we got all these companies. This is, it's like, not to degrade them. They have spent a lot of time and energy into this thing, but they're kind of, in my opinion, following the same mistakes that 2006 to 2020 Silicon Valley did, which is just like, forget about everything else except for the bottom line, and just think about the bottom line. There are really important reasons to focus on the bottom line, but I don't want to. But it's like, I think they're kind of following in those footsteps due to belief structures about the world, and it's just like, I love the fact that you guys are a bunch of nerds, geeks, who are just doing this abstract knowledge representation. It feels like you have the keys to the castle, but no one is the castle.
One quick thing, I got to say, everybody in this field is awesome, and there's all the machine learning engineers are awesome as well. It's just like, we need to pull this all together. And right now we have this kind of like, I think of it as like, not quite a dichotomy, but like symbolic AI and the neural network based machine learning stuff. I also wonder, like, have you followed the story of Jan LeCun? His departure from Meta,
of course, yeah.
And he's on this. I think he's in a different approach to this idea of, like, the idea of a world model. That kind of sounds like maybe a little bit like a knowledge graph, but he's talking about approaching it in an entirely different way. And so I'm open to other paradigms, and I think we all should be as well. That, like, neither of, like, as brilliant as all my, knowledge representation friends are, they're not going to fix everything, and they're the first to admit it. They're the ones who were so excited when LLMs came along, because all the tedious, difficult stuff of building a knowledge graph was suddenly much easier. It's like LLMs are their best friend in that way. But at the same time, LLMs, that I'm not seeing, I guess the thing that's kind of not annoying me, but interesting to me, is that we're not seeing the same love from the LLM side, going like, hey, we can't figure out all these little niggling issues that cause people to mistrust our systems. Maybe knowledge engineering can help us. I don't see enough of that.
And I've researched that exact question to, like, figure out these foundational models, whether they're doing that. And OpenAI made one acquisition, I think for $400 million, of this thing called Neptune, and Neptune helps them do knowledge infrastructure on their model experiments and stuff like that. But it doesn't. But they've approached it from the model of like how to peer into the model rather than how to like think about the LLM itself as this sort of like knowledge thing that isn't appropriately looking at knowledge representation. And there's all these things that you guys have figured out that it just, I agree that they're not looking at. And so I've got to build this chatbot, or I don't have to build this chatbot. I want to build this chatbot. It was really funny because 2 days ago it was like, just build a list, an invariant list. Instead of trying to build an ontology and knowledge graphs, knowledge represents, just build a list of all these terms that I use. But it's still not connecting. Actually, that's a good question for you. Is like at what point do you think a company needs to worry about knowledge engineering, ontologies, and knowledge graphs? Do you think it's like 5,000 people,
Yeah,
10,000?
that's I will, I'm going to put it on my to-do list to do some
Yeah.
research about that, because I don't know, to be honest. I mean, there's probably like, there's probably small companies that could really benefit. Like if you're doing like fraud analysis or, one of the classic use cases where knowledge representation or graph technology, you can do that with like Neo4j or property graph, which is different from the RDF based graphs. But yeah, that's it. I don't, in terms of scale, I think there's definitely a conceptual level at which you're like, this is too complex for even our smartest people and best systems currently, or like for our relational databases to manage and tell us what's going on. And with these handwritten algorithms or, whatever you're doing to reason over it or to try to stitch things together, there's a certain point of which, like the IKEA, that IKEA knowledge graph story is really interesting because that's, if you think about them, they're really simple. They have products and people and stores. There's very few high-level concepts in there. But that product category, boy, does that get big really fast. That's where you get into that C box of all these, is it, all the different ways you can categorize home furnishing products. So they're clearly over that threshold. Once you have like 100,000 products, you clearly need a knowledge graph. But can you get by if you only have 100? Probably. It's interesting to think about. I don't know what the triggers would be in terms of, yeah.
I think I just figured out for my immediate issue, which is the code base. So knowledge graphs so I'll explain what I'm doing basically. So I hallucinated. I love using that word. I hallucinated a planning agent, or I hallucinated an orchestration framework where I use planning agents inside the chatbot. And this is the reason why I'm building a new chatbot is I have my planning agents in a chatbot, and they help me in this linguistic way of like, I just want to have a conversation, a Socratic conversation with this intelligence to understand what I need to do technically. I don't understand enough about the technical details that it gives me. So I have to like consistently like ask it in this way. And then inside the terminal, which is not a place I like being and not a place that most other non-technical people like being, inside of this terminal with a little type and everything like that. It's a really bad reading experience. That's where my coding agents are. But I never read the code. I always copy and paste it into my planning agent and have a conversation about this just like legendary amount of text that the LLM is giving me that I don't want to read. And so I got my planning agent and I got my coding agent. Now, the planning agent is like that needs to have verifiable, truth-based claims about the state of my code base. And inside the code base, I have all this documentation, I have all these tests, and I have the code. The code itself is the single source of truth. So that's what is going on. But I can't read the code, so I can't understand what's going on there. So this planning agent, it's like, how do I make sure that given all the reasoning stuff we've talked about and how the fact that it has no epistemological virtue and confabulates and like hallucinates and makes up facts and all these things, how do I actually constrain that in a way that it knows the ground truth? And I think I figured it out. It's just like, there's got to be, the knowledge inside my code base is rapidly expanding. So there's got to be some sort of knowledge graph or ontology I wonder, do you know anybody who's doing knowledge graphs or ontologies for code bases, specifically for engineers?
Boy, you're reminding me. There was a friend made a super interesting comment on LinkedIn today about he's a guy. He worked at IBM for 40 years, and now he's at Avalara, that tax software company. He made this comment about, have you ever heard of docs as code? This notion that you document your code the same way you would. It's just like code. It's just more of the code. You document as you go, kind of, and
interesting.
You treat and you get version it and you store it and get you version it and all that stuff. He was like basically flipping that around, going, "What about code as docs?" And the thing that blew my mind about that comment was that if you think about vibe coding and the way people are, you can just have a conversation with somebody like Claude and it'll build some code for you. If you put a more rigorous, framework on that, and this might be the kind of thing that might help in your situation, I think. And this is just conceptually. I'm not an engineer. I can't code that for you. But if you think about, just as like software products come out of meetings and people having ideas and sharing ideas and writing them down and then taking those ideas and turning them into code, maybe there's a new sequence that's emerging, that or not a sequence, but a different, that you document it and then you build it, but the source of that is the docs, not the code. Does that make sense?
Yes, it does.
Yeah. And that's what blew my mind about this guy blows my mind every time he writes.
Yes, interesting. But, there it is. Yeah. Because so that is so. I've now built 4 applications. On the 5th application, which is this chatbot I'm talking about, that's what I've been doing. Is I've been doing a bunch of deep researches, building the docs, and not building until I've got the docs in the way that I want. So there's the knowledge graph or the ontology. So I got to figure out a way to build a knowledge. Should I use a knowledge graph instead of SQL?
Oh, that's a good question. What are you putting in what's the SQL database? Like how many tables and what's all in there?
So I now have a SQLite database that is holding all of my session details and my chats and all the things that are, I think I should. Okay. So I have an SQLite, but that's for the chatbot itself, but I should build a knowledge graph or an ontology for all of the docs to determine what is true, what are decisions, what are the invariant things. Those are all the things. I think that's what I got to do to basically.
Yeah, I'll try to remember to share with. I'll see if I can find them. I've got a whole bunch of tabs open with information about. One of the things that came out of the context graph thing is this notion of decision traces.
Yeah,
that's just one part of what you're talking about, and I think some of the other stuff might be analogous. And I wonder, like decision traces, that kind of reads like transactions, which probably is the kind of thing that's better stored in a relational database, but I don't know. Again, that's above my architectural level because it gets more like technical decisions about performance, and because you're probably going to deal with it even with your small thing. You're already hitting. You need to scale, basically. Right?
Yes. Yeah. Well, and just given the vibe coded nature of everything that I've built so far and my inability to verify, this gets into a whole other thing that we can spend the next 5-10 minutes on, which is OpenAI tried to figure out how to do a universal verifier. So they tried to basically how to verify anything in any domain. The reason why coding is such a good one is because we have all these tests and we have all these ways that coders have figured out how to do epistemology inside the code base that lend itself really well to a verify. So a coder and their test suite can verify almost anything that is coding based in nature. But what happens if you get into physics? Or what happens if you get into mathematics? Or what happens if you get into biology? How do you create a universal verifier? And OpenAI has tried to figure out. I don't think they're gotten very far with it. Forgot where I was going with that. But what do you think about universal verification?
That's a really interesting, because that to me that just screams out for like a knowledge graph solution. Because you're talking about facts, like vetting things against facts. Yeah, and you can't rely. I mean, this kind of gets into like, it seems like the evolution of augmenting LLMs with knowledge. It started with RAG and then graph RAG, and now it's agentic stuff, and it's there's a lot of other things they're integrating with. But what you just described is like okay, we need to vet this
Yeah.
decision or this idea or whatever against
Yeah.
validated, verifiable facts. That's one of the things that knowledge graphs are great at. And in fact, with RDF 1.2, it adds even more ability to do like provenance and pedigree and to assert opinions about stuff. Like you can have degrees of certainty now. A lot of this is stuff that label property graphs has done for a long time, but now you can do with RDF 1.2. So some of that stuff you're talking about, like how confident am I of this? I don't know exactly what your chatbot is processing, but that notion of accounting for agreed upon facts, not a vectorized embedded version of language about those facts, that just screams out to me for a knowledge graph. Or some kind of knowledge representation. Yeah.
Knowledge representation. So and this is the hardest thing for me because it's just like, where do I begin for RDF? Maybe I just need to build an RDF. That's going to be interesting to like how to get into how to train and I think I got to take a course and Jessica Talisman's course looks pretty good.
Yeah, I did that course. It's really good. Yeah.
Oh, you did? Okay.
Yeah.
You did the course.
The Knowledge Graph Academy. Yeah.
Yeah. Okay. Well, my mind is full. So thank you so much for coming on the show. And can you share the link to the podcast?
It's just kgi.fm is the short URL. And and Jessica's been on there, lots of other fascinating folks. So, yeah. And I love what you just said. A quick thing about what you just said.
Sure.
This comes up all the time. Is we need to be better at onboarding. Making it easier for people like you to get on board with RDF. And I would let's keep that conversation going because I want to help. It needs to be easier, and I'm here to help. So
it's a small group of insiders who all share the same language, and they're also obsessed with language and getting language down to its roots, which makes me really interested. But I think, how do you actually bridge the gap?
Well, it's built into the practice. We know how to deal with abstraction. We just need to abstract out these principles in a way that's relatable to a noob to the discipline.
And that's why I've wondered why people like Jessica, why people like you, or like why all these people are so good at explaining things, and it's because they're so good at abstracting things. Is that right?
I don't, to be honest, for me, it's just immersion and then parroting what I've heard, and then validating against the reality that smarter people and I have articulated. Is just, just like learning. I think this is kind of what Jan LeCun is on too, is like that turning learning into knowledge. Like there's knowledge capture and knowledge representation is one way of doing that. But I think I need to go to school more on what he's up to. Because he's got $1 billion to play with. I'm sure he's making some discoveries. I'm interested to see what he comes up with.
And the interesting thing there is that he raised $1 billion at a $3 billion valuation, and he told all of his investors that this is an R&D. This is pure R&D. We are not getting into any sort of product yet because we have to build this whole architecture that the LLM guys have already built since 2015 or earlier. Thank you so much for coming on the show, and go listen to the podcast.